Again, welcome to College Algebra. In this section, we are going to study about quadratic equation. This is our Unit 7 lecture number 4. So our main objective is to learn how to solve quadratic equations using factoring and also square root property. Also solving quadratic equation using completing the square. So those two objectives is using factorization, two different techniques of factorization. Then step 3, we solve the quadratic equation using quadratic formula. Then we're going to determine which method or strategy is the best. Also, we can solve formulas for a variable that is squared, define and use the discriminant, and also go through how to write rational equations in quadratic form to solve the equation. So first we start with solve quadratic equation using factoring and square root property. So again, a quadratic equation is an equation that can be written in this form: ax squared plus bx plus c equal to 0. The highest exponent is 2. So where the a, b, and c are real numbers, and x squared or x in general is a variable. And that's our main goal, is to look for the value of x. And this given form again is called the standard form of a quadratic equation. So first, solving the quadratic equation again using the zero factor theorem. Using the zero factor theorem process is 2. First, we have a quadratic equation. So we are going to factorize it so that we get 2 binomial multiplied by each other. Then we are going to equate each binomial to 0 and find the value of x. So those are the 2 steps. So that's the example here. If a and b are real numbers, and let's assume that a is one binomial, b is another binomial, and they are multiplied together, we get ab equal to 0. So it's the same as a equal to 0 or b equal to 0. So let's see an example. Hopefully this example may help us to understand. So here they say we should solve a quadratic equation 2x squared minus 9x equal to 35. So first I'm going to rewrite the equation so that I make sure everything equal to 0. So we are going to bring the 35 to the left side. Since 35 is positive value, when you cross the equal sign, it's going to be negative. So here we have 2x squared minus 9x minus 35 equal to 0, which is the same as 2x squared minus 9x equal to 35. So now I'm going to factorize my trinomial or the quadratic equation here. Using try and error, the method of, again, factorizing a trinomial, we get 2x plus 5 multiplied by x minus 7. Again, I'm not going to explain this step because we cover it in our previous lectures. And when you go to a lecture, how to factorize a polynomial, trinomial, we use 3 different techniques. So this is where we use the zero factor theory now. Since we have 2x plus 5 multiplied by x minus 7 equal to 0, I'm going to write 2x plus 5 equal to 0 and find the value of x, and also x minus 7 equal to 0 and find the value of x. Normally, most of the time, quadratic equation will give us 2 values for x because the higher exponent is x squared. So that's what we did here, 2x plus 5 equal to 0. So 2x will give us, again, 5 is positive. When you cross the equal sign, it becomes negative. Then 2 is multiplied by x. When 2 cross the equal sign, it's going to divide. So our first x value will be x equal to negative 5 by 2. Then the second, we have x minus 7 equal to 0. Minus 7 cross the equal sign, it becomes positive 7. So our final solution will be x equal to 7 and also s equal to negative 5/2. Sometimes we can check and make sure our answer is correct. So when we plug minus 5/2 into 2x plus 5, we substitute x with 2 times minus 5/2 plus 5. The answer should give us 0. And here we can see that when we substitute s to 7, it will be 7 minus 7, which is 0. So 0 equal to 0 means the solution is correct. So this is our square root property. Now here we say that if s squared equal to 6c, then s's answer is 2 options, either square root of c or negative square root of c, which sometimes we can write in the form of plus or minus square root of c. So solving quadratic equation using the completing the square. So we already went through the techniques of using the completing the square method of factoring an equation or factoring a polynomial. So this method is based on the following product. I have s squared plus 2ax plus a squared is the same as s plus a all squared, or s squared minus 2ax plus a squared is the same as s minus a all squared. Again, this is called the perfect square concept, which we also cover during the factorials of a polynomial topic. So the strategy for completing the square: first, if the coefficient of s squared is not 1, then make it 1 by dividing both sides of the equation by the coefficient s squared. So first we have to make sure that the s squared coefficient is 1. Then if necessary, we should add a number to both sides of the equation to get a constant on the right side of the equation. So the goal is we want to take all the values to the left, the constant value to the left. After that, then we complete the square on x using the completing square by factoring techniques. Then we identify the coefficient of x, take 1/2 of it, and square the result. Add the number found in part A to both sides of the equation. The number found in part A is after we identify the coefficient of x and take 1/2 of it and square the result. So after we finish with that, we factor the perfect square trinomial and combine the like terms on the other side. Then we solve the resulting quadratic equation by using the square root property. So let's see an example. Hopefully this example may help us to understand the concept. So here I have s squared plus 4x equal to c. The goal is to find the value of x, which is solving the quadratic equation. So here we say the coefficient of s squared is already 1. So we don't need to change it to 1 by dividing everything. So we leave it as 1. Again, when we look at the steps here, let's go back 1. The first thing they said that if the coefficient of s squared is not 1, make it 1 by dividing both sides of the equation by the coefficient of x squared. So here it means if, for example, I have 3s squared plus 4s equal to c, I'll bring 6 to the left side and I'll divide the whole equation by 3. But here, since again the coefficient of s squared is 1, we leave it as it is. So next, since 1/2 of 4, the coefficient of s is 2. So we can say 2 squared equal to 4. Then we add 4 to both sides. So here we get s squared plus 4x plus 4 equal to 6 plus 4 again. Then by substitution, we get s squared plus 4s plus 4 equal to 10. We had 6 plus 4. So here we get s squared plus 4s plus 4 equal to 10. We can see now this is a perfect square. So we get s plus 2 all square equal to 10. Then we use the square root. So I take the square, cross the equal sign, becomes square root. So we get s plus 2 square root of 10. And s will give me minus 2 plus square root of 10. Or s plus 2 equal to negative square root of 10. And s will give me negative 2 negative square root of 10. So now solve the quadratic equation using quadratic formula. We know quadratic formula always is minus b plus or minus square root of b squared minus 4ac over 2a. Again, a, b, c are real numbers. So this assuming s square coefficient is always a, s coefficient which is always b, then c is always a constant value. So based on our example, whatever we have is what we are going to represent with a, b, c. So an example is given here, 2s squared plus 8s minus 7 equal to 0. We should solve this quadratic equation. So if that's the case, we know s square coefficient is 2. So a is 2, 8 is b, and c is a constant value, negative 7. So we plug in the values in the formula. So we get minus 8 plus or minus square root of b squared, which will be 8 squared minus 4. A is 2, c is minus 7. Divided by 2 times 2 because a is 2. So 2a will be 2 times 2. Then we can again solve this problem in the square root. Together we get 120. We can check one more. And we have 4 times 2, 8. And then 8 times negative 7. I think that will give a 56. Then 8 squared will give me 64. So we find the difference of the two. And we remember we have negative, so it turns to positive, then we find. So we get negative 8 plus or minus square root of 120. So when we go through, our final answer will be minus 4 plus or minus square root of 30 over 2. And we can write the answer as minus 4 plus square root of 30 over 2. And the second is minus 4 minus square root of 30 over 2. So now they say we should determine the easiest strategy to solve quadratic equation. I always prefer the formula because, again, all we need, if I know the formula is minus b plus or minus square root of b squared minus 4ac over 2a, and I know the a is the coefficient of s squared, b is the coefficient of s value, and c is the last constant value in the quadratic equation. So the example here is a equal to 2, b equal to 8, c equal to negative 7. So I'll just plug in this a, b, c values in the formula, and then we solve it. So here it's very straightforward if you know the formula than using, again, factoring techniques. So this is the strategy to solve the equation, the quadratic equation, and trying to determine which techniques or method will be faster. So here we say if the type of the quadratic equation is as squared plus bs plus c equal to 0, where the left side factors easily. So as squared plus bs plus c can factor very easily. Then I'll use factoring. So use factoring and the zero factor theory. So example, I have 6x squared minus 11x plus 3 equal to 0. I was able to factorize 6x squared minus 11x plus 3 very quick. So I will use factoring. So I get 2s minus 3 times 3s minus 1. So we go through the process of solving it. Then we get s equal to 3, 2, and also 1/3. Now the second one said if the equation of the form as squared plus bs equal to 0, where the constant term is missing and the left side factors easily, then still we should use factoring. Since it's factor easily, use factoring. So example is 9x squared plus 6x equal to 0. We can say the common value here, or the term here, will be 3x. 9x squared plus 6x, we find the common value among them, or factor among them. So that would be 3x. So 9x squared divided by 3x will give me 3x. 6x divided by 3x will give me 2. Then I say 3x equal to 0, so s equal to 0. Or 3x plus 2 equal to 0, then s will give me negative 2 over 3. 2 is positive, cross the equal sign, become negative 2. 3 is multiplied, cross the equal sign, is going to divide. The same thing applies to equation of the form ax squared minus c equal to 0. We should still use the factoring and the zero factor theorem. Now, equation of the form ax squared minus c equal to 0, or s squared equal to k, where k is constant, then we use the square root property. Now, if we have equation of the form s squared plus bx plus c equal to 0, where b is an even number, we can use completing the square. So s squared minus 4s plus c, we can see that again, the middle value is even, or the b is even 4. So this is the same as writing s squared minus 4s equal to negative 6. I move the 6 to the right side. So from there, we follow the steps here to complete the square and solve the problem. Next, they say if we have ax squared plus bx plus c equal to 0, where the left side cannot be factored, or cannot be factored at all, then we use the formula. So anytime you have a quadratic equation and it's very difficult to factorize, the best way is to, again, use the quadratic formula. So here we have 3x squared minus s minus 5 equal to 0. The best way is to use the formula. So solve formulas for a variable that is squared. So they say many formulas involve quadratic equations. For example, if an object is fired from a ground level straight up into the air with an initial velocity of 88 feet per second, its height is given by the following: h equal to 88 t minus 16t squared, where h represents the height in feet and t represents the elapsed time in seconds since it was fired. And we can see that based on the formula given, we can say this is a quadratic equation because the highest exponent is 2. So we have t squared and plus 88t. So to solve this problem for t, we can use the quadratic formula because it's very difficult to, again, factorize it since we are using equal to h. H also is a variable, it can be any value. So here we get 16t squared minus 88t plus h equal to 0. So we plug in the values. Again, a will be 16, b will be negative 88, and h will be positive 1. So again, that's the formula we have here. S equal to negative b plus or minus square root of b squared minus 4ac over 2a. And b squared minus 4as is always called the discriminant. The discriminant can determine the number and the nature of the roots. And also it can tell you how many x values we are going to have. So if discriminant is 0, it means only one repeated rational number. So it means S will be only one value. Now, if discriminant is positive and or perfect square, then we have two different rational numbers. If it's positive and not a perfect square, then we have two different irrational numbers. And if it's negative, then we have two different non-real complex numbers. We mean the discriminant value, which is b squared minus 4ac. If the value is negative, then we have two different non-rational complex numbers. So here they say we should determine the number and also type of roots of an equation 3s squared plus 4s plus 1 equal to 0. So first we calculate the discriminant, which is b squared minus 4ac. So here we can say b is 4, a is 3, c is 1. So we just plug in the value. The answer is 4, which means it meets the first condition we said, second condition we say positive and perfect square. So since a and b and c are real numbers and the discriminant is positive and the perfect square, then the roots will be two different rational numbers. Okay, so our next step is write rational equations in quadratic form, then solve the equation. So this means we are going to be given any expression. So example here, we have 1 divided by s minus 1. Again, 1 divided by s minus 1 plus 3 divided by s plus 2 equal to 2. Again, 1 divided by s minus 1 plus 3 divided by s plus 1 equal to 2. So in order to solve this problem, first I'm going to simplify the irrational expression here. So here we can see that our SCM will be s plus 1 times s minus 1, which is a difference of two squares, s squared minus 1. So we multiply with the left side and also the right side to balance the equation. Anything we do to the left side, we have to do the same thing to the right side. So by doing that here, we can see that we are going to cancel x minus 1 here, and here we are going to cancel the s plus 1. So what will be left in the first term here will be 1 times s plus 1 plus 3 times s minus 2, because s plus 1 cancel. And s minus 1 times s plus 1 will give me s squared minus 1. So we end up having s plus 1 plus 3 s minus 1. So we can open the parentheses, we get 3x minus 3. And also we can open the parentheses here, 2s squared minus 2. But I have 3s plus 3s, and I have plus x. So plus 3s and plus s will give me 4x. I have minus 3x, minus 3, and plus 1 will give me minus 2. So when we combine these two terms here, we get 4s minus 2. Then we move everything to the left, and we combine the like terms together. We get minus 2 and plus 2, they will cancel. Then we have 2s squared minus 4x. So now we can solve this equation. So we can see by looking here, we know this is again a quadratic equation. I can use the formula saying that a is 2, b is negative 4, and c is 0. Or we can see if we can factorize it. 2s will come out, then we get s minus 2. So our answer will be s equal to 0 and also s equal to 2, which is what we have here. So I have 2s squared minus 4s equal to 0. I factorize 2s out. So I know 2s is common in both, divisible in 2s squared and 4x. So I'll get 2x a square divided by 2s will give me x. Then minus 4x and positive 2s will give me minus 2. Again, dividing. Minus 4x divided by 2s will give me s cancel s, 4 can go into 2 is 2, and negative divided by positive will give me negative. So here we can use our square root. So 2s equal to 0. We can use factor 0, 2s equal to 0, and s minus 2 equal to 0. So s minus 2 equal to 0 means s will give us 2. Negative 2 cross the equal sign, it becomes positive 2. 2 divided with 0, so 0 divided by 2 will give me 0. So the final answer will be s equal to 0 and also s equal to 2. So in these lectures, we learn how to, again, solve quadratic equation. We can use factorization or we can use the formula. And we were advised that if it's easy to use factoring, then do factoring. If it's not easy, then use the formula. So again, I'm going to end this section here and wish everybody the best.